Hello, this is Adam Cohen. I am the Regenerative Explorer in Residence at Passive Buildings Canada, and I welcome you to my personal observations of Energiesproung. As you've seen from the previous presentations by Peter, Daniel, and Mark, Canada is making some real strides in the implementation, nuts and bolts, of net zero renovation using the Energiesproung model. But one of the things that I observed in my study of Energiesproung, and I have been advising NYSERDA with their Energiesproung program that's trying to bring industrialized net zero renovation to the state of New York. And I have also been liaising with the Natural Resources Canada group and have been to the Netherlands to see with my own eyes what's going on. And there was really some basics about Energiesproung that I want to bring to North America to let people know how the European model, the Netherlands model, does have a significant difference with North America. So the very first thing to understand is that the Dutch have made a societal commitment to pulling their climate change weight, okay? 35 to 40% of greenhouse gases in Holland are generated in the building sector. This is very similar to every other developed nation. And Energiesproung, when it started, it didn't start out saying we are going to renovate multifamily buildings or social housing. What Energiesproung did is said, we need to make a difference in the built environment as to our impact on the climate change imperative. What can we do? So they started out studying many building sectors to see what they could do. And what they realized was that in order to get to where they wanted to be, which was cost neutral, net zero renovation of existing structures, social housing seemed to have the largest potential and was the easiest to aggregate the demand. The other thing to understand, this is really important, that Dutch social housing organizations and the social housing structure in general is structured differently from the US and Canada. Social housing associations, which are the groups that hold the properties, are given loans based on the organization's loan-to-value ratio for their entire portfolio. If the loan-to-value ratio is less than 65%, they get the loan. No competition for money or tax credits. So this way is quite different. If they decide they want to do a project, they can do a project. So this loan is not tied to the property, it's also tied to the worth of the entire association. So there's associations that have thousands of units, and many of these units were gifted to them a long time ago, and many of these units have very small amount of money owed against them, but are in dire need of a renovation. The other thing to understand is that the Dutch housing associations group together to self-insure as a group. So as a way to deal with the Dutch social housing in general, the Dutch have constructed a system that makes it much easier to put actual projects on the ground. The other thing, which I find, this is really not relevant necessarily to Energiesproung, but I found this to be amazingly open-minded, forward-thinking, just a way to think about social housing. In the Netherlands, if you get into social housing and your income goes up, you don't have to move out. In fact, you can live there and you can let your kids live there after you. This builds pride of place and community and gets people much more comfortable with their neighbors and their community, and you're not having people constantly in and out. And so what you see is, even though it starts out as social housing, low income, it ends up as a mixed income property over time, which is wonderful. Now, what happened was that as Energiesproung started, the people who were starting Energiesproung they were looking around and they realized that social housing had the opportunity to aggregate the demand, that they could put a lot of properties together. And what they said was, you know, in order to get to the scale, the market to the scale that they needed to have a large number of units ready for renovation that could be funded so that they could interest providers that were going to provide the services to the social housing organizations. They wanted providers to say, be interested. And for these large providers to be interested, they needed to know that there was a market. So there's a potential in social housing in the Netherlands of 100,000 units that need renovation. So what they did was they aggregated approximately 11,000, 10%. And they did it in a soft aggregation. So basically what they said, of the 11,000, they have a hard commitment to do 6,500 units. When I was there in August of 2018, about 2,500 units had been completed. And the goal is through this industrialization process to lower the cost and get the market rate net zero goal by 2020. So that means that if you can get this to where the energy savings and the energy generated by the solar panels can offset the cost of the renovation, that means that opens the entire market rate market in the Netherlands up, which means all the multifamily and all the row houses. So it's a pretty exciting and pretty major endeavor and pretty ambitious, but they've inspired people all over the world. So let me go over some of the actual costs and numbers. As of when I was there, and in discussing this with people who have been there recently, it has not changed a lot. Their market rate break-even cost for net zero under today's conditions for the units that they have is approximately 45,000 euros. The initial projects that they did, the very first projects they did, were running over 100,000 euros. Not surprising at all. Currently, the cost to get to net zero, or at least the cost was when I was there, was about 65,000 euros. Now, these are net numbers, not including HST, GSTs, because they differ by country, and I don't want people to get confused by adding those percentages. These are the actual cost numbers, not the tax numbers. The cost gap is being closed, and it was really interesting. You know, how can you build these buildings if you only can offset with 45,000 euros and it's costing you 90 or 100,000? How do you offset it? This was just mind-blowing as an American coming to the Netherlands and talking to people, and I kept asking the builders and developers, well, how's the gap being closed? How's the gap being closed? And it wasn't until I actually met someone from one of the municipalities we visited that he told me, he says, oh, don't worry, this is way too important a problem for us to let money stop us. So what the banks did was they just extended the lending terms out to 40 years and lowered the interest rates to less than 2%. Right? They just said, we need to make this work. We need to make the money work because this is an imperative for our children. Now, a little bit of editorializing, I wish we all thought like that. So the builders are the spear point of the Energiesprung. The builders are the ones that are implementing these details. And when I talked to Peter Amarongen 2 years ago, when he was just starting the Pier project with his Sundance project, he said to me, you know, when he asked Jasper van de Munchkopf, who is one of the founders of Energiesprung, about details, what he basically said was, look, we have no real library of building details we can share. We've learned that so far that the building details need to come from the manufacturer of the component being supplied. And to have an architect design details of prefabricated panels results in an incredibly inefficient process, because the panel manufacturing plant and the panel manufacturers understand that they are optimized to build their panels in a certain way. And to get an architect-led project that has a panel that is not optimized for their factory just results in one-offs that are high costs. And so what Jasper said in essence is that he would rather come up with a functional specification for the envelope and forget about the details, partner with good panel manufacturers and other people that are providing components and let them meet the specs. The other piece of this that was pretty important was they wanted to draw in the builders and the manufacturers. They wanted the builders and the manufacturers to put skin in the game. So why would they do that? Why would a builder or a manufacturer go in and invest money in this? They did it because they could see the potential market demand. They understand the climate imperative in a way that we don't in our guts, like North American. Don't forget, Holland is basically below sea level in a lot of parts. So this is something that they worry about. They understand. One of the things that was really interesting as I went in here to visit the Energiesprung people in the Netherlands was what the builders had to say, right? Since they're the tip of the spear, I really wanted to talk to them. So there were 3 builders I got a chance to talk to. The first builder had a yearly volume of 40 million euros. Pretty decent volume. And I asked all 3 the same question. What is your break-even throughput? In other words, how many units do you need to put through your system in 1 year at the current cost of 65,000 euros, right? Because we're not at 45,000, but they're roughly at 65,000. What is your throughput that you need? And here's the interesting thing. The first builder, whose volume was 40 million, needed 200 units, and he was going to hit that volume by end of last year. The second builder, builder number 2, his yearly volume was 1.2 billion euros. And that same question, how many units throughput do you need to get through and hit break even at the $65,000 euros was 500 units. The next builder, builder number 3, his yearly volume was 1.4 billion euros. So these are some large firms. Their break even was 600 units. Now, the interesting thing is builder 2 and 3 hit their break evens in 2019. So they are getting there, right? They're slowly getting there. But the thing to understand is, if you look at it and say, what's the difference between these 3 builders? The difference is overhead, right? How much overhead they can contribute to each job, what's the cost of their overhead, and how much of that overhead will be covered with each unit. So you can see, as the builder providing solution gets larger, the amount of units that it's going to take to make them have an interest or skin in the game gets larger too. And that's an important thing to understand for policymakers, because the startups are generally done with people bootstrapping and don't have a lot of money unless there's a market there. And then you can interest the people that actually have larger quantities. Now, I was able to talk to 2 different manufacturers and ask them similar kinds of questions. The first was a panel manufacturer, really amazing factory that was automated with robots and CNC and computerized manufacturing in a pretty slick operation. They were currently, as of 2018, at 400 units, approximately 5 panels per home. Their break even at the $65,000 level, because we didn't get to the $45,000, the 60, where they were today, was 800 units, which he hit this year. And his factory capacity, this is the interesting part, is 3,000 units. So they hit the break even and now they're getting into some gravy, all right? Manufacturer number 2 was of the HVAC pod. The HVAC pod is a little unit that comes out and attaches to the building from the exterior that has heating and cooling, if they have cooling, hot water, the solar inverter, and controls. It's got the monitoring system. So the HVAC pod is quite a complicated little beast that has everything all in one. They were currently in 2018 at 300 units. Their break-even throughput was 400 units, which they hit in 2018. And this year, 2019, they're looking at 1,200 units. So they're doing pretty well. So you can see that this idea of aggregation of demand to get enough interest from larger performers seems like something that makes a lot of sense. So when you look at this, you know, what that tells us is that scale makes a difference to profitability for these companies. And so what we have to say is, how does that guide us in North America? How can we take this understanding of what they're doing and guide us, right? It gives us a metric to entice builders, right? To once we understand what that throughput needs to be, so we can know how much demand we have to aggregate to actually put together to interest larger people. Now, the next thing is, you know, Energiesproung, they're at 65,000, they need to be at 45,000. They've been on a glide path from over 100,000 down to that 45,000. So the glide path to market rate net zero requires innovation, because you can't do it off the cuff. You have to innovate to cut costs. That's very, very important. This is not off the shelf technology. If you do it off the shelf, it's going to be too expensive. And the other thing is that the glide path is not certain. Nobody can tell you exactly what you need to do. They're feeling it out, but they're very determined actors in this, and they're very committed to the ultimate goal of dealing with climate change. And this is really an important factor, because the idea in North America that we would do the type of things that they've done in Netherlands is really exciting if we can actually get it off the ground. Now, the other thing, and I think this has the chance to really change the way that the industry is working, at least in the Netherlands, is that the builders are required to give a 40-year performance guarantee, meaning that they have to guarantee that the building will be net zero over time. And the interesting thing is that they generally agreed to this, but what they've actually agreed to in hard contract is that they will commit for the first 10 years, and then they will re-examine it after 10 years to figure if the program needs to be tweaked, because they're gathering data. Nobody's done it before. And it was really interesting. I was with a fellow from New York when we were touring these Energiesproung plants and talking to builders. And he said, well, after 10 years, he could just walk away or whatever. And I said, no, come wait a second. They're all doing it in good faith. They're all pulling in the same direction. And he just looked at me and goes, I don't know that would work in North America. Maybe not. It's something to do with your heart, right? Not necessarily your head. So if you're working in good faith, you're working in good faith. Okay? Now, there are some requirements that go into this to help the builders. One is it requires that the housing associations hire the builders for yearly maintenance on the units. So there's an ongoing income stream for all the builders. Second, it requires monitoring, because the monitoring is key to making sure that the net zero performance is happening, and if it's not happening, why it's not happening, right? So they look at hot water usage, and they might be able to tell that folks are using more than would be normal. Or I saw one project and it was on the street, and there was a big tree and it was shading one unit's solar panels. And I asked the fella, you know, what about that tree? It's shading your panels. There's no way, you're cutting down your production so much. There's no way you're going to produce enough to get to net zero. He said they were already in conversations about cutting the tree with the local municipality. So the other thing is that this really requires good faith among stakeholders. People have to be aligned around the mission, and they need to really all pull in that same direction. I asked some of the builders if this 40-year performance guarantee concept is bleeding over into their standard work, and he told me that yes, they're starting to get requests from their clients to give them performance guarantees. So here's my final thoughts. Here's my thoughts on this. I've given a lot of thought of how do we bring this to the United States or to Canada? And we've done a lot of analysis on the existing situation in New York State through NYSERDA on the costing. And one of the issues that we see is that it's really hard to capture the energy savings and to get a fair return for that investment. So as a result, there's not an intuitive number out there that you can say, this is how much per unit we can afford to spend. When we did that analysis, when one of my colleagues in the NYSERDA program did that analysis, they were only able to come up with between $8,000 and $10,000 per unit in New York for the cost of getting to net zero, which is obviously way too low to get it there. So this is the way I see it. We need a market case, which is a business case, right? And you need to take that market rate case and break it down in some large meta metric like dollars per unit. Okay, X per unit, X per square foot, X per square foot of envelope area, whatever you want to do it. But I think dollars per unit, that's a pretty reasonable meta metric. And then you have to ask yourself, is this reasonable? Yes or no, right? So right now, if we look at New York State and we say $8,000, we say, no, that is not reasonable. We're not going to do net zero renovations for $8,000 a unit. So that's a no. So as soon as we say no, we have to go back around to revising the business case to figure out how much we can actually do. Now that's what New York State is currently doing. They are currently working hard to aggregate demand and try to figure out how to get the financing, get the numbers together. And they're going to keep going in this loop until they get a number that they feel is comfortable, right? Now, once we get to a number, let's say we get to a number of $60,000 per unit over the cost of a standard renovation, and that's able to be financed, and that, you know, we have a number that we can say we have a source of funding, we have a source of demand, which is the aggregated units that need to be done. Now we just need providers. And this funding that we have, we think is adequate. And so let's take just some number, $60,000 per unit. That I have no idea if that's the real number or not. So what I think is once the group, the government, has put together the pipeline and put together the financing instrument, then they put out a request for proposal for a business plan. And now it would be me as a provider. For me as a provider, the way I would do it is I'd go into my cost code data from all my jobs. I'd mine this business as usual data for my costs. I would determine what those costs would be to get to net zero. I'm sure when the first numbers are done, it's too high. That's what we found in all 6 of the projects with NYSERDA. We're also finding that with similar projects in Canada. The cost of these first projects are high. This is what Energiesproung found. We're seeing very similar numbers in North America, in both Canada and the US, to what Energiesproung found. So it's not what the current costs are necessarily that the person is going to write their business plan around. What they need to do is look at the current cost. If the current cost is, say, $120,000, you need to get to 60, you need to create a theoretical net zero cost model. Okay, a theoretical net zero cost model is one that says, what does the future look like in a situation where we have aggregated demand, access to funds, and are able to move this forward, and our goal is to hit this magical $60,000 number, and our current cost is $120,000, right? So that's where the entrepreneurialism, the creativity of the business owner comes in, where they develop this cost neutral net zero cost model. And then they have to ask themselves, Is this a realistic target? Can I innovate and get myself there? If not, go back around and keep working. If it is, well, that's pretty easy. From that number, you determine your break-even throughput. And that's the number that the folks that are aggregating the demand need. So to determine their break-even throughput, let's say you have somebody and they've got a company of 40 people. And for their break-even throughput at the $60,000 in 5 years, let's say in 5 years, they're going to say, well, I need 350 units, right? And then we go down to the next builder who's even bigger. And this bigger says, I can get there in 3 years, but I'm going to need 1,000 units, right? This is what they need. This is what we need in the governmental side from the private side, to tell us what's the throughput at that number that you need so we can get this aggregation and this source of funds together. And then once that throughput is determined, the state or the agency that's working on this has to say, is this cost and this throughput a reasonable way to move forward, right? And can we aggregate the demands? Well, I mean, if somebody comes and says, well, I need 10,000 units by year 5, to get there, then that's probably not realistic that we're going to get 10,000 units. If somebody else says I need 100, that's probably more realistic. So that's where the choices have to be made. If they decide the cost and the throughput is not reasonable, then I think that's the end of the process, because why waste your time going any further? Although, let's go the other way, and we said, yes, we're actually going forward. Then we design and build the first projects, which actually we're doing in both Canada and the US, as you have seen from the Canadian. And then it's just a continuous improvement process of test, refine, test, refine, test, refine, test, refine, test, refine, and we zero in slowly on that magic net zero market rate that we're shooting for. So I know this is a little bit in the weeds with the numbers, but I think it's really important to understand that to really change the industry, to really make the difference that we need to make for our children's future, we have to work together across industry and government to put this together, prioritize the climate change imperative, and make these numbers work for society. As my colleague in the Netherlands said, this is too important a problem not to deal with it and to let money stand in our way. Really, really take that to your heart. Too important to let money stand in our way. I thank you very much, and I hope you've enjoyed this, and I look forward to our conversation at the Lunch and Learn. Thank you.